All right, wonderful. Well, hello everybody, and welcome to the fourth session of Next Economy North Bay's Action Climate Change Guest Speaker Series for 2022. My name is Alex Miller, and I will be your moderator this evening. In my day job, I work alongside Simon, who, well, I'll talk about him a little bit shortly, as the Sustainability Officer at Rethink Green. We're just delighted to have you join us this evening, and I hope that you'll also be able to attend our final talk next week. Last but certainly not least, we're going to be hearing from Simon Blakely, my colleague, Program Director at Rethink Green, who will be talking about the low carbon economy. If you're interested in attending, be sure to register on Eventbrite or join us on Zoom again, and I'll be posting that link in the chat momentarily. Some housekeeping matters before we get going. I'd like to remind everyone to remain muted throughout today's presentation, though feel free to keep your camera on if you want. If you have any questions, please make a note as we go along, and we'll allow time for a sort of question and answer session at the end of each of the presentation. And I certainly encourage participation. You can either raise your hand or the hand signal, and if you'd like to ask a question, or of course, feel free to place it in the chat if you prefer. Our speakers will also be pulling together resources like the slides and contact information, and I'll forward that along to you in the days coming after the presentation. So, of course, before we dive in, I'd like to acknowledge the Robinson-Huron Treaty of 1850. And the land on which we are gathering today, commonly known as North Bay, is situated in the traditional Anishinaabe territory on lands occupied by the peoples of Nipissing and Dukes First Nations. I'd like to acknowledge how grateful we are for the opportunity to gather today and thank all the generations of people who have been stewards of these lands. We recognize and deeply appreciate their historic connection to this place, and we also recognize the contributions which Métis, Inuit, and other Indigenous peoples have made, both in shaping and strengthening this community in particular, and our province and our country more broadly. As settlers, this recognition of the contributions and historic importance of Indigenous peoples must be clearly connected to our collective commitment to deliver on the promise and the challenge of truth and reconciliation in our communities. And because we're gathering remotely via Zoom, it also means that we get to connect with people from all across Turtle Island, which means our land acknowledgements often should also stretch beyond where we are just physically here, North Bay. And so if you're joining us from afar, please, if you're comfortable, share in the chat where you're joining us from. So I'm going to give a brief overview of what we'll be covering today. For anybody who's attending this series for the first time, I'll give a brief introduction of Next Economy North Bay and also Rethink Green, including a summary of our newly launched program. I'll tell you a little bit more about that in a minute. And then I'll introduce Dave Smits, partner at Induspec, who is our guest speaker for today, and he'll be delivering his presentation entitled Sustainable Building Design. Following the presentation, we'll open up the floor for Q&A. So anyone new to the call, or perhaps watching this on YouTube, you might be wondering, what is Next Economy North Bay? So founded in early 2019, Next Economy North Bay comprises a grassroots collective of local business and community leaders who are seeking to build capacity so the city of North Bay and surrounding communities may become leaders in the modern low carbon economy. It aims to provide a local, reputable, and publicly accessible body of knowledge, information, which acknowledges the existence of climate change, and at the same time showcasing some of the many ways communities, businesses, and households can transition to a cleaner, greener, and more equitable economy. To date, the group has organized public-facing events, including North Bay's first Sustainability Expo in 2019, their first Commuter Challenge, which coincided with Canadian Environment Week in June 2021, and now this, our first guest speaker series, with 5 guest speakers presenting on their knowledge and expertise over the course of 5 weeks. And we're in week 4, which is wild. I can't believe we're already here. As if we're wrapping up just next week. For the further information and to show your support, check our activities on Next Economy North Bay's social media pages. You'll find us on Facebook, Instagram, and YouTube. So Next Economy North Bay is a shared platform of Rethink Green. Rethink Green is an environmental programs incubator, which offers a variety of programs and services that bring together ideas, partners, resources, just to build sustainable communities here in northeastern Ontario. And the organization creates community networks which promote creative collaboration and dialogue about local and global environmental issues and empower our member organizations to meet their environmental and sustainability goals. So, as today's presentation will include analysis of the technical issues as they relate to newer sustainable buildings, especially opportunities to achieve energy efficiency gains in new housing developments, I figured I'd take a few minutes just to share some information regarding what can be done with our existing housing stock. Typically, when we think about net zero, sustainable buildings, we might envisage new builds. At least that's what a quick Google search gave me, and that's what you see here on the screen. These will often take the form of modern, fresh-looking developments which incorporate, plenty of glass for passive lighting and heating, green roofs and living walls, providing valuable amenity space or sustainable drainage options, plus habitat areas, to support the birds and the bees. And renewable technologies, maybe in the form of, solar panels or mini wind turbines. In this regard, it would be easy to assume that by knocking down older and less efficient buildings and replacing them with newer designs, we can save on our total energy consumption and reduce our greenhouse gas emissions in the longer term. And that may well be the case where a building has been deemed obsolete, or even where another overriding environmental benefit can be achieved, such as removing and safely disposing of hazardous materials, like say asbestos. Oh, I missed a slide here. There we go. But by choosing to demolish some of our older buildings on the grounds that they no longer meet our current needs, we are failing to embed more circular practices, which could reduce the amount of waste generated through the effective reuse or recycling of existing building materials. In making such choices, we should consider the amount of embodied energy already contained within these existing structures and the historic emissions already released through the process of designing, building, restoring, and maintaining those assets. We need to think about the energy consumed as new materials are manufactured, distributed, sold, transported, and then assembled. Can they be sourced locally, regionally, provincially? Can they be sustainably sourced? Some developers are taking this to the next level by choosing to deconstruct rather than demolish existing buildings. This can involve taking buildings apart piece by piece and avoiding damage by carefully extracting what is required. And by taking such an approach, we can not only save on purchasing new materials, but positively reduce the amount of materials, noise, nuisance, and dust associated with more traditional demolition and reconstruction methods. And as we continue our conversations on how to achieve that goal of net zero emissions by 2050, we will also need to determine what actions we can all take in our own homes to increase energy efficiencies. And that's kind of, where Rethink Green can help. As mentioned earlier, Rethink Green will soon be launching our new Northern Home Energy Assessments program, which we recently hired a new staff member who's currently training as a registered energy advisor to provide home energy assessments in Greater Sudbury, North Bay, and beyond. The training process is extensive, but our energy advisor will soon be ready to deliver home energy assessments to EnerGuide standards, allowing households registered in the program to potentially access government grants, incentives, and other rebates. These can be used for a range of purposes, including renovations, improved home energy efficiencies, and ensuring that our older buildings stay resilient to the effects of climate change. The process for applicants will include sort of getting registered with Natural Resources Canada, booking and receiving your initial assessment. So our energy advisor will come to your house and determine the exact amount of energy your home is consuming. This is commonly referred to as a baseline assessment. And then the energy advisor will then draft up a report outlining your home's current energy use and make a list of recommendations for improvements. They will also provide estimates for how impactful the recommended improvements will be in the form of percentages. And then the homeowner will then complete the renovations and they must make sure that they kind of keep all those receipts because they're going to come in handy. Our home energy auditor will then return to the property and verify and document the works that have taken place. And then those tests will be repeated to measure the difference in the building's energy performance, sort of a before and after. Once confirmed, the applicant is required to submit the necessary documents online using the NRCan portal, which they previously registered for. And there, they will also upload those really handy receipts. And if the works are deemed eligible, the householder could receive rebates under the Canada Greener Homes Grant and the Enbridge Home Energy Efficiency Rebate, which offers up to $5,000 in rebates plus $600 to cover energy assessment costs. These opportunities to leverage, but there are opportunities to leverage both of these programs as they have different requirements and varying amounts of funding available for each upgrade. Such strategies can be discussed during the final visit, and we can make sure that homeowners can claim the maximum amount for their upgrades. If you're interested in receiving that service, you can join our waiting list, and you'll find that. I'll send that link as well. And I will share the link in the chat momentarily. So now to talk a little bit more about the importance of sustainable buildings, it is my pleasure to introduce today's speaker, Dave Smits. Dave is a professionally certified mechanical engineer who graduated from Carleton University and went on to fulfill senior executive level positions in the construction and healthcare sectors, with an emphasis on strategy, quality improvement, and project management. Dave's 30 years of experience includes positions at Ontario Hydro, Union Gas, and the North Bay Regional Health Center, through which he has gained substantial experience in the maintenance, safety, and reliability of nuclear power production, natural gas distribution, facilities management, and modern methods of construction, among other focus areas. Dave takes pride in being a lifelong learner. He's completed additional training in lean, process improvement, risk management, health and safety, and recently passed the CEM, which is the Certified Energy Manager examination. He has completed parts 1 and 2 of the Passive House certification process and is now working on completing a certified project so he can obtain his final certification. All right, Dave, so the floor is all yours. I'm going to stop sharing. I'm going to admit. There you go.
Thanks, Alex. I'm going to share my screen so we can get started. Hopefully it works as well as it did when we tried it a few minutes ago. All right, so I'll start the presentation. Come on, slideshow. There we go. Can everybody see my first screen? Okay, we're all set. Thank you so much for that introduction. And I really appreciate talking about your reference to existing buildings. This first slide, sustainable building design, what's different? So when you look at this picture, what this is a thermographic image of 6 buildings, brownstones in New York City. And the one that seems darker than all of the rest is one that has had a energy efficient, a deep energy efficient retrofit completed on it a few years ago. So the ones that you can see all the yellows and reds, that's heat loss. So what you're seeing with a thermal imaging camera is where the heat is being wasted in those buildings. That building that's blue is how, through the renovation activity and the improvements that are made, how much of an improvement could be achieved. And visuals are often, very powerful in explaining what can be accomplished. That's what's different when we talk about improving buildings. In my presentation, I'm going to talk a fair bit about new construction, but a lot of what I'm talking about is absolutely applicable to renovation projects as well. And Passive House has a deep energy retrofit, EnerFit program targeted at renovations, because we cannot replace all the buildings we currently have, nor should we, for the reasons that Alex already talked about. So quickly, an agenda. Who's Induspec? I'm going to do a little plug for the company at the beginning. What is sustainable building design? Just a couple definitions. Why we should build this way when we're building new, but also why should we renovate this way? I think is completely applicable. How do we do it, right? What's the approach? How do we make it happen? Sort of is another sort of piece of that puzzle. And at the end, I will talk about the embodied carbon issue, because it's not just about using less energy in the buildings that we either have now or have in the future. But we also have to think about what we're building these buildings out of. And as Alex said, we've got to reuse the buildings that we already have to the greatest extent possible, because the production of building materials is a large source of carbon, but I will get into that a little later as well. So just Induspec, we've been around since 2010. I've been with the organization 5 years now. Our motto is sort of boots on the ground. Myself and the other engineers in our office like to not only sort of provide the analysis and reports for our customers, but we actually want to see those reports implemented and ensure that their projects are completed. So we spend a fair bit of time providing sort of on-site sort of support to our customers. We again try to distinguish ourselves by that hands-on approach and on-site approach. We have a number of pieces of equipment. So the other thing we've gone out and invested in is lab-grade thermography equipment. So the picture that you saw on my first slide, we can take those sorts of pictures and do that sort of analysis of buildings. We've got bolometers. These are pieces of test equipment for looking at air systems in buildings, ultrasonic flow measurement to look for leaks in compressed air systems. We've got data acquisition units for checking electricity consumption. We have industrial blower doors for doing leak tightness testing, similar to what would be done if you had your home energy audit done. The person that comes in to do that first assessment is going to test your building for leak tightness. So we have that kind of equipment and use that equipment to help solve problems for our customers. Big chunk of our work is based on repeat business. So we thankfully can develop relationships with our customers and therefore get to continue to serve those customers going forward. Sustainable building design, I pulled a couple sort of definitions, right? Meets the needs of the present without compromising the ability of future generations to meet their own needs. To me, that's a pretty fundamental definition of sustainability. Sustainable living approaches can reduce environmental impacts by altering the built environment to create more sustainable cities. That would include sustainable transport, zero emissions housing, as well as sustainable architecture and circular flow land use management. And that's kind of a fancy word for what Rod Bills was presenting on a few weeks ago in terms of how do you revitalize your cities, how do you create healthy cities, and what does that look like, as opposed to continually expanding and building new subdivisions? How do you do effective infill and really create vibrant communities with walkable spaces and those sorts of amenities? So over the last 3 weeks leading up till today, I think many of the issues or items that support sustainability we've already heard about, right? With our kickoff presentation providing sort of a broad view of what actions various municipalities are taking to move forward. Rod's presentation in terms of how to make a vibrant city and how to help it be sustainable. And then last week, looking at transportation sort of options and opportunities. I think we've been building on sort of this theme all the way through, obviously, the speaker series. Why build this way? Well, this is an old slide. It goes back to 2010. Unfortunately, the slope of that line hasn't gotten any better. We continue to see atmospheric carbon dioxide and the whole issue around 1.5 degrees. I think we've all heard plenty of that over the last few years. I just pulled some stats in preparing for the presentation from the period of, and this is from Enercan, so reputable source, but from 1990 through 2017, energy efficiency in residential buildings in Canada improved by 30%. So 27 years, 30%, a little bit over 1% a year. I'm not sure if anybody other than me thinks that at that rate, we're not going to solve our problem and be able to hit 1.5 degrees if we're going at 1% a year in terms of improvements. It just doesn't seem at a rate that's anywhere near aggressive enough. Is that really a path to sustainability? And I think that's why things like Passive House and these deep retrofits and net zero has become part of the conversations that we need to have, because our current rate of performance improvement is inadequate. It's not going to do it. And I guess today in Ontario particularly, maybe not in Toronto because some of the standards are different, but in much of Ontario, you go to build a new home and you ask the home builder, well, how much is it going to cost me to heat it? Or what my utility bills will be? they don't really have an accurate answer for you because they don't model that in advance. They don't do the analysis to figure out, well, what will it be? And then how accurate is that analysis really? The other thing is, in a home today, if you're building a new home, the inspection that happens is a visual inspection, right? So you're actually building probably the most important and expensive asset that you're ever going to own. And the various components have certification on it, but the assembly as a whole, the only testing that's done is actually a visual inspection. There is no requirement to do an actual performance test on that building. And I don't know about the rest of you, but if I was told the car that I'm in hasn't had sort of crash testing and other sort of performance testing done on it, I don't know that I'd want to be driving in that car. So why is it that we live in homes that haven't had that testing done? And we don't actually know what the air quality is, to be frank, right? Because that's not checked either. And there's really no way to be doing that, or it's just not done consistently. So how do we make this happen? I want to introduce you to sort of Passive House. For me, with the training that I've done the last few years that Alex already mentioned, I've become, I guess, a significant advocate for this method of building, because after having the training, you start to realize that why have we been doing anything other than this in terms of how we build our buildings? So Passive House can achieve performance improvements over today's buildings of between 50 and 70%. And 50% is on a renovation, doing those sorts of improvements, 70% or more on new build. And that's over a 2017 building, not over something built in 1990. So we're not talking 1% a year anymore, right? We're talking deep improvements that can make a significant difference. Not only does it reduce your utility costs, because you're now going to know what your utility cost should be, because it's all modeled in advance with tools and techniques that are reliable and have been proven to be reliable. But it also improves your comfort, improves the air quality in your home, and makes your home more resilient in the event of a disaster. And I'll talk more about those things as I go through the rest of the slide deck. And then it follows with, testing during construction. So as you build this building, you actually test it to confirm that it's going to perform the way you expect it to perform. And you're going to get those advantages in terms of comfort and air quality, and all of those other things are going to happen reliably. It also makes the path to net zero much easier, because if we reduce the amount of energy these buildings need by 70 or 80%, think about how small a solar system you need to put on your building to actually be net zero at that point. So it all sort of lends itself towards sustainability. I'm going to do a small plug. I've been working with Andrew Peel of Peel Passive House for the last number of years on a local project that I'll talk about a bit at the end of the presentation. And Andrew has shared sort of his Passive House slide material with me, so that I could shamelessly plagiarize a bunch of the next material that I'm going to share from the material that he presents during the courses that he teaches. So if you have any interest in being Passive House certified or to get any further training, Peel Passive House can provide that to you. So I wanted to put that plug in because he was gracious in sharing his material with me. This is some of what he does. So, the Passive House Consultancy, he does training, he does certification, he does research. He's probably one of the top minds in the province, if not the country, as it's related to Passive House. The one picture here at the top that you see above Passive House Consultancy, he's actually certified a Subaru dealership in Alberta to Passive House standards. So house is, in German, is building. It's not a house. So this isn't just about residential construction. This is about all types of construction. So he's actually built and certified a car dealership, just to put it into context. So again, we're, energy demand for Canadian homes and buildings, just touching on this again. This is some data, goes back to 2013. Again, it hasn't improved dramatically, as I said earlier, 1% a year. So the data is not going to be much different on this slide deck. But you can see that with Passive House, when you add in where we'd be performing in comparison to these other bars, the space heating bar chart is dramatic. right? I mean, it's this kind of improvement that now makes net zero so much more, so much easier to accomplish. Domestic hot water, there are improvements because we think more carefully about the hot water system, design it more efficiently. Appliances, we're selecting better quality appliances, Energy Star certified, those sorts of things. Lighting, again, optimizing lighting and using techniques, and space cooling, again, is done more efficiently. But I mean, when you think about Canada and you think about energy consumption, this is the one that I hope sort of catches your attention. You know, and so that amount of decline, 15 kilowatts per hour per meter squared per year, that's the target for Passive House. So to be certified in a certified project, you will be at or below that target. 90% reduction. So I've talked 50 to 75 because I like to be conservative, but many projects are accomplishing 90% over building code sort of buildings. That's the degree of improvement we're looking at. So, you know, how much is 15 kilowatt hours per meter squared per year? So let's look at this, right? 2,000 square foot home, you know, 300 liters per year of oil. I mean, this is what it would typically take in a conventional code built home, right? So lots of oil or natural gas, depending on what you're doing. So we're talking 2,000 watts now in a Passive House home, similar size, right? So a traditional heating system is no longer required. So you're not going to put a traditional furnace in a Passive House. It's not necessary, it's overkill. And you basically could heat it with a big hair dryer, right? So with effective design, really thorough planning, thinking about where your sun is, and I'll talk more about some of those considerations later, this is the kind of performance improvement we're talking about, right? And I think, again, it's pretty compelling when you think that this is what is achievable and not is being achieved in many parts of the world and here in Canada now in a number of projects, which is great. Essential elements. So in Passive House, you know, what do we look after? What are the things that we want to chase down? So this diagram is meant to show that thermal insulation. So we have targets that we want to hit in terms of how well insulated our building is. We want to avoid thermal bridges. And what a thermal bridge is an area in your building where you end up with less insulation in a specific spot because of how the building is constructed, where all of a sudden you've got, let's say, a 2x6 constructed house today, but at the corners where the 2x6s meet and you can't put insulation in that corner, or you can put very little, instead of an R24 in that corner, you might have an R5. Well, that corner is a thermal bridge. And there are thermal bridges around your windows. Typically, there's thermal bridges where your wall meets your roof. So that the design practice with Passive House is we eliminate to the greatest degree possible through effective planning those thermal bridges. We pick good windows, right, that have high performing glass and high performing frames. And we ensure that we've got an airtight envelope. And then last, we make sure that you can still breathe in this house, because obviously if we've made it this tight, we've just moved you into a swell water bottle, and without giving that building some air, it's not going to be very comfortable. So we put a very effective heat recovery ventilator on the house or on the building so that we can ensure that you get fresh air coming into the building, but that fresh air has a high degree of heat recovery so that the energy being used is minimal. So this is the key. And what happens in terms of this, the air tightness has got to be less than 0.6 air changes per hour at a certain pressure rating. That's compared to most code built buildings today are in the range of about 2.5 to 3 air changes per hour. So just to put it into context. Primary energy demand, all sources below a certain level, and I'm not going to spend too much time on the technical stuff. And frequency of overheating in the summer has got to be less than 10% of the time. And why this is an issue is when you've made it this tight, if you get solar gain in the summer and you're not thinking about how you're shading your building, you can actually run into the situation where overheating becomes a problem. So you'll want to make sure that you've taken that into account in your design and you eliminate that risk from an overheating perspective. So what's actually happening when we do this, right? 19th century, we built buildings, we put large furnaces in them, boilers, big stoves, whatever the case may be. We went around with sweaters on, and that's sort of what our buildings were. 20th century came along and we decided we could fix it all with technology. So we're going to have building automation systems, and we're going to have really fancy mechanical systems and really fancy heating systems. We're going to do all kinds of stuff. And that's what we did in the 20th century. And we all see that at 1% a year, those approaches have been pretty much ineffective. I mean, it's been nominal improvement. 21st century, in a passive house, we actually spend the time paying attention to the building envelope itself, get that part of the building that is sort of so fundamental to the building, we get it right. And then what happens is we actually have very simple mechanical systems and very minimal mechanical systems, but we have a far superior building in terms of its comfort and its resiliency over time. So flexible aesthetics, people like, Alex showed some pictures at the beginning, right? Some different building types. Well, passive house, I mean, we can, we're looking at different forms. It's not, people often think, okay, you're probably building this little box with these little windows and it's going to be dark and it's not going to be very aesthetically pleasing. And the fact is, there's a wide range of passive houses of varying different formats being built around the world. So we're not constrained by sort of the aesthetics. We're not constrained by, we're encouraged to do good planning and to make sure we've done proper planning up front before we start building something. Again, a little bit more on why passive house. So superior indoor environment. So air, thermal, and acoustic. So we know how much air we're getting because we're controlling the airflow, and we know what quality of air because we filter that air. So we've got a certainty around air quality that you don't have in your house today if all you're counting on is what leaks through the walls and windows in your building today. Thermally, the temperature in these buildings is very constant from room to room. It is almost, it would be the same across any room in the building. And I'll talk a little bit more about not just the same from room to room, but in a room, also the same as even as you get close to the outdoors and to the glass in your room. Acoustically, these buildings tend to be extremely quiet because they are so well insulated and their windows are such good quality that if you're living in a busy neighborhood with lots of outdoor noise, the inside of your building is very, very quiet. Resilient and durable, I'm going to talk about a bit more. I've got some slides that talk about timeframes in terms of how long they'll survive with power out before you get down to temperatures that could be a problem. Depending on where you are, it can take days to cool in a power outage and may never freeze just because of the nature of how it's built. 25 years, I mean, this has been around for a long time. In other parts of the world has been certainly accepted. Some countries have made this their building code in terms of energy. We haven't gotten that far yet in North America because energy has traditionally been cheap, but obviously that's changing. It's accepted and sought by occupants in many parts of the world. It delivers true greenhouse gas emission reductions, and it's backed by robust third-party quality assurance processes. So the certification of these buildings, if people take it to that extent, give you that assurance that you're going to get the building will perform the way you expect it to perform. And that's the advantage of certification. Works in any and every naturally inhabited climate. So this isn't just for warm or moderate climates or super cold climates. Based on the design principles, it can be made to work anywhere in the world, and it does today. I'm going to talk a little bit more about comfort. One of the issues, I think, if I live in a early 1960s house here in the city of North Bay, and I've done lots of renovations over the years, but I can tell you when it was 30 below a few weeks ago, if you go and stand close to your window, you often will find it quite chilly because the actual temperature in front of that window is quite a bit different than it is in the balance of the room, often 4 or 5 degrees different. So if you've got a chair close to the window on those coldest nights, you're typically not sitting there, or you're drawing some curtains, or you're doing something to try to take the chill off that window. And often there's got to be a heater in front of the window to take that chill off the window. So in Canada, where do we put our vents from a forced air system, or where do we put our radiators if it's a baseboard? We put it in front of the window. Why? Because the window's cold. That's why it's where it is. In a passive house, we cut that temperature differential by 3-4 degrees by picking a better window. So all of a sudden, you don't have that same discomfort, you don't have that same need, and therefore you don't need to put the heater below the window. And we actually looked at this. We were building a new hospital here in North Bay 15 years ago to see if we couldn't find better quality windows to avoid the perimeter heating system. And at that time, we couldn't get reliable window data to give us the confidence that we could do this. But that was the principle, was better windows meant we didn't need the radiant heaters in front of the windows. But unfortunately, we couldn't do that then. So I talk about reliability of results. So one thing that Passive House has done is they've gone back, each of these blue lines is going back to buildings that were built in these various cities in Germany and comparing what they saw in energy performance to what the calculations were. So for each of these 4 buildings, you can see this red line, and there's some variation around the line, but that variation represents that Dave likes it 20 or 21, somebody else likes it 18, somebody else likes it 23. But basically, in terms of the performance that you'd expect, you are getting exactly what you would expect out of that envelope. That envelope's performing the way you would expect it to. And the examples of the buildings that they were testing are sort of shown here in the pictures in the background. So the reliability of this process is a significant selling feature. Again, performance, so not just new, right? This is a retrofit. So you've got a block of buildings from the 50s on the one side, after it was fully renovated, had a new exterior and a bunch of other upgrades completed on the right. And here's the before and after thermography images. So the one on the left shows all of the heat coming out of all of the various locations in that building envelope. And the one on the right is showing that that has been, for the most part, completely eliminated. The windows will always be where you're still going to see some heat loss, but the windows are an incredibly important part of any building. So it's a matter of managing that and minimizing it by selecting very good windows. Resiliency, just to touch back on this, this is analysis from Toronto Zero Emissions Building Framework. So they did some modeling to say, as they move through the various tiers where they're going to be requiring better and better efficiency over time, sort of what would happen in a power off winter temperature in Toronto. And we certainly understand Toronto's not North Bay, it's typically more moderate, but you can see the difference as time goes on and how much longer you can remain in that building as that building envelope improves in terms of the power going out. So when you get to tier 4, which would be close to where Passive House is, in a low rise, or sorry, in a high rise building, after 2 weeks, you're still between 15 and 20 degrees Celsius. So you're never going to run into freezing in that unit. It's not going to happen. So the resiliency in terms of shelter in place is built into the building once you improve the envelope to the degree that I'm talking about. So, you know, Passive House delivering on promises since 1991. I mean, that's some of the earliest buildings that were built to this standard. So it's, you know, the possibility and integrity are some of the things that I've touched on so far. But I'm going to go a little further because I want to show some examples. You know, 40 countries at this point, sort of what other building standard or rating system has such reach? Not many, not any that I certainly know of. So we're talking around the world, from China to Australia to North America, South America. It is starting to be more and more embraced as what we need to do in the future to accomplish the goals that we have in terms of sustainability. Here in Canada, a number of different projects, everything from condo towers to EMS buildings, tower retrofits. So the city of Hamilton has done a project where they've taken a derelict high-rise building and they did a deep energy retrofit on it and put that building back into service and achieved performance improvements in the range of 70% or more over what the building was originally. So that's the Ken Sobel project in Hamilton, and that was completed last year. And now, of course, work is happening to see where else they can do those kinds of deep energy retrofits. Car dealerships, as I said, so it's a full range of buildings. This isn't just about houses. This is about virtually any building that we build. Economics, so people often now think, well, okay, so it's going to cost a whole lot more money to build buildings like this. And for countries that have been in this now for a while, there is that initial increase in cost as the industry comes to terms with the different construction process. But what's now happening is those same countries have looked at various methods to improve construction processes, including prefabricated wall systems, prefabricated mechanical systems, so that construction can happen so much more quickly that in places like Belgium, you've seen cost actually be less, 10% less than conventional construction was before they made the switch to passive house. 90% sold in 6 weeks, sold at the same price as a standard building. So they didn't have any premium that they needed to put on those buildings when they sold them. Affordable housing in the UK, 10 to 15% higher rents, lower rent arrears and turnover, because it's very, very cost effective to live in these buildings. In Vancouver, they're actually experiencing premiums that people are willing to pay on townhomes that have been certified to passive house standards, because the lower operating costs provide an advantage over time. So there's actually an inherent value increase that you're seeing in these high performance buildings. Pennsylvania has done a number of geared to income housing projects now with passive house as the standard. Their initial projects were coming in 3 to 5% above sort of code built buildings, and the last several projects have come in 3 to 5% below those code built buildings. So as the trades get used to what it means to build these buildings, and better planning is sort of built in, where the savings come in is you're avoiding these elaborate, complicated mechanical systems, and those savings help offset the majority of the costs that you're seeing in the envelope. And in many cases, they're actually as cheaper than a code built building. Canada, the good news is we are getting some made in Canada sort of passive house products. So these are just a few companies that are out there now that have been sort of embraced this. Quantum Passive House is right here in the province of Ontario, and they've actually got wall systems, prefabricated wall systems that are certified to the passive house standard, and that are prefabricated and be shipped to your construction site, so that assembly on site often takes somewhere in the 1 week to 2 weeks, and your building is enclosed and the roof's on, and you're finishing the inside of the house once these panels arrive on site and your foundation has been pre-poured. So I mean, those are some of the advantages in our Canadian climate around speed of construction, and obviously superior performance. Political developments. Good news is there's leaders everywhere, but in this case, City of Vancouver is moving aggressively. The BC Energy Step Code has started to make it very clear to builders in BC that by 2030, they intend to be essentially, or 2032, they intend to be essentially a passive house standard in terms of energy consumption, 15 kilowatts per meter squared per year. So they've made it very clear to the industry that we got to get this figured out. Also in BC, they are working through aggressive sort of getting rid of gas, essentially. So electrification of the buildings in BC are also happening on essentially that timeline. So the intention is to no heating being done with gas or oil past a certain date, and that date is actually only, I think, a few years away now. So it's coming up quite quickly. Toronto Green Building Standard, same thing. By the time we get to tier 3 or 4 in 2030, they'll be at this performance standard. National Energy Code, they are working in this direction, but again, the National Energy Code gets accepted at different rates by different provinces. So that's where, again, a province like Ontario hasn't taken as decisive a position in terms of moving in this direction. And ASHRAE is working aggressively on matching their standards to the standards in Passive House. So lots of really good work happening sort of at that level, but we know we only have so much time given the targets that we have around 1.5 degrees. So it's something we got to move quickly on. Remember, large buildings have long development cycles, so it takes time. A couple more, York Region, I mean, police stations, EMS, maintenance yards, they're planning to have Passive House on public buildings starting in 2025. So they're just setting it as a standard. That's what they're going to do. As a municipality, York Region, that's what they're doing. City Housing Hamilton, I already talked about the Ken Sobel Tower. They're doing a number of Passive House projects and will be doing more. Ottawa Community Housing has already built a Passive House project, and in their particular project, the total utility cost, because again, this was a social housing development, so smaller units, but the annual heating cost for these units was $50 a year. So I just want to let that sink in for a second. I said $50 per year, right? That's what we're talking about in terms of annual heating cost. So, and these projects are here today, they're up and running, they exist, right? This isn't just a future looking thing, this is now, right? So summary sort of outlook for PH, we at this point are seeing massive growth and interest with active projects. And I'm going to talk about at the end some different links you can go to if you're interested in reading more. There's some really good communities that have developed over the last 3 years that want to share, promote, and support this type of building practice. And I'll share that at the end. Growing market for forward-thinking companies to capture, but not only companies, it's municipalities. Like I said, City of Ottawa and many other cities, this is what they're doing with their social housing stock, right? They are setting the standard to say, we're going to do deep energy retrofits and we're going to build to this standard. In the Netherlands, about 6 years ago now, they started a program called Energy Sprong. And the goal of that program was to do deep energy retrofits, first and foremost on their social housing stock, and then they're expanding to all types of buildings. And in this last period of time, they've taken the cost of doing those retrofits and cut it by 50%. And they've taken the schedule and reduced the schedule by more than half. So now they can do a typical duplex in a week at half the cost of what it cost before. And they accomplish energy improvements of 50% or more over what it was with improved air quality, improved thermal comfort, all of those features, and it's a week, right? But that's applying prefabricated techniques, that's applying really efficient planning, and that's really driving the industry to make those sort of things happen. But that now is happening in many countries in Europe, but it started in the Netherlands. Challenges to overcome, that's what this speaker series is about, right? Awareness. We want everybody to be demanding sort of this sort of improvement, because it's very achievable. This isn't just pie in the sky. We should push governments to mandate this stuff, as we see happening elsewhere. We have to get more Canadian-made products, because right now we still ship in a lot of products from elsewhere to hit these high performance requirements. And we certainly know here in Canada, we have the capability of having these built here. Skilled professionals and trades. It's a very specific approach to training, and that needs to be embedded in our training. And then the code barriers that exist, we need to be continuing challenging those code barriers to be able to make sure that we don't stop ourselves from accomplishing these types of performance improvements. So summary, world leading high performance building standard, proven, cost effective, high occupant satisfaction and acceptance, driving innovation, future-proof, climate change resilient, and foundation for net zero energy home and building. So when you've built it like this, putting solar panels on that building is a very cost-effective solution, because you just don't need very many of them. And then leaving a positive legacy. Who's this for, right? This is for our kids, our grandkids, and the generations that come after us. I mean, that's really what we have to be trying to continue to remind ourselves of. I want to just touch very briefly on embodied carbon, and Alex talked about a bunch of this at the beginning, so she did a great job really covering the major issues. Is construction material choices are an important consideration. So we can't afford to, and nor should we, rip down all the buildings we already have. That's not a path to sustainability. And actually between now and 2030, when we've got to hit this 1.5 degree target, what's probably more important than how much energy our buildings are using, which needs to get less, as I've already described, how much energy, how much embodied carbon is in the materials that we're producing to create those buildings is absolutely critical. Because to hit the 2030 1.5, a lot of the experts that I'm reading are saying if we don't deal with the embodied carbon issue, the operating carbon issue that I've already talked about is not in itself going to solve our problem, right? It's not just about operating carbon. We have to consider embodied carbon. It's critical. So construction material choices are critical. Building life cycle considerations are critical, right? We don't just tear them down. As Alex said, if you pick the right building materials like prefabricated wall systems and other components, in the future, you can deconstruct that building and reuse many of those components, right? But you got to be thoughtful about how you go about designing and building those buildings. A few pieces, and actually I'm just going to go back. I want to go back one more, hang on. So if, again, all of this stuff is of interest to you and what I've said sort of piqued your interest, then the good news is we're building a project here in North Bay with Brandon Hale is the developer of this project, and it's on the city's waterfront. And we are actually targeting to be Passive House certified. So this will be an 8-story condominium building times 3 over time. The building will be Passive House certified, and we're looking to use mass timber for the construction of that building and a number of other very positive embodied carbon materials in terms of that building construction. So Brennan is a forward vision sort of person who is driving the change locally, because as part of this project, we've already trained in terms of Passive House a number of the local design firms, a number of the local contractors, because to be involved in the project, you've had to agree to take the Passive House training. So these people have been trained, and now we're starting to build that capacity locally. And that's because one person has a vision and a drive that he wants to see something different than the typical condominium project that you see built that is at best code minimum. I mean, that's typically what's done because they're purely maximizing profit. And what's left is a building that doesn't perform particularly well over its life cycle. And Brennan wants to do that very differently. So his tagline on the fence when you drive by the site says, we don't build them like they used to. And in this case, that's a really good thing, right? That we don't build them like they used to. So then just wrap up, I've left some stuff on the slide deck that you can choose to go take a look at your leisure. These are just some things that I use as references on a regular basis if you want to read some more and learn some more. And then once you get down this rabbit hole, you can spend an awful lot of time here. Take it from me. So that's it.
Thanks so much, Dave. That was fascinating. That was awesome. That was really fascinating. You know, like passive housing is definitely like a newer kind of concept for me. I haven't known about it for very long, but it was like back in the fall when we had our business forum that I first realized, you know, maybe my eyes were open to passive housing a little bit, because one of our Green Economy North members, Judy Sumner, she went off and started telling us all about these like nifty little projects she had going on in her house. And she was telling us about all these like passive benefits that she had, and sort of, and, you know, passive like comforts based on where her windows were, where she decided to plant her trees, and they, you know, and like what that did for the temperature of her house. She's a chemistry teacher by training, so it really translated well. So that was really great. But so thanks again, Dave. That was awesome. I did get a question in the chat for you, wondering what your thoughts on reestablishing the home energy rating and disclosure program that was canceled back in 2018, what your thoughts on that were.
I think those sorts of programs are critical. We have to be able to define we have to create incentive in various ways to encourage sort of that improved construction and renovation sort of approach, right? So the rating systems on buildings start to create a real opportunity and incentive for people, because if your building is going to be significantly poorer than other buildings in terms of its rating, its value is going to be affected. So naturally, it creates this incentive for you to want to have that perform better. And again, you're back to, without it, how do you know how your house is performing, and is it performing as well as it should? And I don't mean just performing from an energy perspective. How good is your air quality? I think I was telling you before that the session started, a little story about a friend of mine who decided to pick up a CO2 meter. So he lives in a 1970-ish home here in the city of North Bay. It's a very nice house in a very nice neighborhood. And he's done retrofits to it over the years, new windows, and done a bunch of different things, and decided, based on some reading he was doing, he wanted to put a CO2 meter in his house. So he put a CO2 meter in, did some reading, and it says you should be somewhere 700 or 800 parts per million or less in your home. That's sort of good level for CO2, and pretty much any building, actually, because in the hospital we used to keep it 700 or less was a target that we were looking at to have good fresh air, a good indication of fresh air. So he put it in just before Christmas, and then his daughter, his 3 children, his son-in-law came home. There were 7 of them in the house doing Christmas type festivities, and his CO2 alarm's going off. And it's 2,200 parts per million. Right? So that makes you groggy, makes you sleepy, really not very fresh air. And you start to wonder, well, what else is in the air in your house? And the fact is, if you're cooking with a gas stove, unless you've got a really high efficient range hood over your gas stove, there's all kinds of stuff in your house in terms of stuff in the air that ideally wouldn't be there. But this is not something we tend to worry about, although we spend so many hours a day in our homes. And now during COVID, we've spent even that many more hours a day in our homes. But we don't even certify these homes. We don't test these homes. You buy a new house and the inspectors walk through it. He's looked at it and said, yep, it follows the drawings, it meets code, but there's been no testing done.
I don't know if anyone has any follow-up questions to that, or if anyone else has questions, feel free to. Joanne, yeah, of course, go ahead.
First, Dave, thanks for the presentation. I'm really, really happy to learn tonight that this new condo is going to be passive housing. Yeah, and you're involved with it for.
Yeah, well, I've been working with Brennan on sort of the energy side over the last sort of 3 years. I guess we started together on it when he was looking at this mass timber development, and as we did some more homework together and studied opportunities on the energy side, pursuing passive house became sort of his clear preference and direction, and thankfully that's the direction we're moving in. So yeah, we're excited. I mean, we're going to get building number 1. Our intention is to certify. We're going to get as close as possible to certifying as we can. Of course, there are financial considerations. You have to take that into account. But at the same time, when you're targeting this and doing the planning that's already gone into that building, this building will still perform 70 or 80% better than a non-passive house building, even if we don't get the plaque for the wall, because the testing will still happen. All of those things will still occur. It just may be that we don't get the plaque for the wall. But we'll see. I mean, our goal is still to be a plaque on the wall if we can.
Yeah, a great marketing tool too, to help sell. The other thing, I don't want to put you on the spot, but I guess I am, but just thinking of the net zero emissions, I now regret, like I came into this game 10 years too late. From day one, I thought Castle Home, that building, it's not good for a nursing home, but it's good for other things. And in my mind, I'd always saw social housing and social agencies and services in that building. And when you think of just instead of destroying that one, just taking it to another location and building the new one, but keep repurposing this one and making it that much better. So I guess I know you work on that project, but just from zero emission, that would have been the decision to take, correct? Like to.
I think in the case, and again, I came into this the same time that you did later. And as I understand it, as they weighed the benefits of trying to keep that old building and repurpose it, as we've already talked about, is an important consideration versus the benefits of that campus that they've created around seniors care, and looked at those considerations. The folks that did this analysis previously kept coming back to the value of that campus of care from a senior's perspective as having significant value beyond potentially trying to repurpose the old parts of the building. Because the challenge with some old buildings, that I was involved in the old hospitals. So it was the same issue with those buildings. When we looked at it and said, hey, can we repurpose these? Is somebody willing to step forward and do the work to turn this into different type of housing or some other use? And nobody would touch it with a 10-foot pole because the cost was so prohibitive. Because frankly, in the old hospital as an example, and Castle Home is similar, so much of the infrastructure has gotten so bad, the ability to retrofit it is now very challenging from a cost perspective.
Okay,
there are buildings that do get past that useful life piece because we just didn't do a very good job building them 40 years ago, unfortunately.
Okay, thanks a lot.
You're welcome.
Just do a quick follow-up actually on the Green Vision development on the waterfront there. I understand it's going to be possibly the first of its kind, a condominium of that building of that size to be a passive house standard in Northern Ontario. So it's actually kind of a landmark project in the city, right?
It's certainly in Northern Ontario. I know there's 2 other condominium projects happening in the province that will be passive house certified as well, at least 2 at this point, but they're all in Southern Ontario. So in terms of tackling this climate, because we are in a different climate zone, as you all know, right? Toronto, Hamilton, that's a different climate zone than North Bay. So when we take it to North Bay, the planning piece, again, requires certain things to be looked at even that much more carefully to ensure you can hit those standards.
Yeah, that was going to be a second follow-up, and I expect to be a really detailed technical answer about the way the ventilation systems are designed. So maybe we won't go down the rabbit hole tonight. But I do understand that you're looking at wood-based construction as well for that development. Have you had any kind of involvement in that side of it, and how, going back to the concept of embodied energy that you mentioned, that trees obviously, naturally store carbon. So what about that as a material for?
Yeah, absolutely. I mean, the building started with, that was the focus, was using mass timber as part of the construction. And then we talked about, well, what else could we do over the last few years? But mass timber was key. We see mass timber as an ideal building material. The way that mass timber elements, glulam columns, and CLT sort of floor plates are built is by cross-laminating timber, we can make very strong structural components that will last indefinitely, right? If you put them in an appropriate environment, put a good building envelope around them like we're going to do. I mean, we've seen lots of wood buildings that have lasted 150 years and are still standing and still look fine. What damages wood is moisture and rot. And by building a better envelope around this building, we've almost guaranteed that the life cycle of this building is really indefinite. The advantage with wood as well is when you're building it in a factory the way that we are and the way it will be for this project, you can machine it to tolerances that are millimeters. So when the building's put together, it fits very, very well. And in the case of one of the projects that we've been trying to emulate is the Brock Commons University residence in BC. So this is an 18-story student residence that used mass timber as its structural system and used a prefabricated exterior wall system. So the exterior wall system was prefabricated, windows already installed, siding was already on the outside of the building. So what they did to prepare is they poured the concrete foundation, they poured the elevator shafts and stairwell, was concrete in that case, 18 stories high, and then they had it sitting there. And then from when they started to put the rest of the building up with the mass timber elements and the exterior, it took them 9 weeks with a construction crew of 8 people. And at the end of that 9 weeks, they were putting the roof on the building. This
It's
is an
quicker too.
18-story student residence. So if you look up Raw Commons on YouTube and watch the time-lapse video, you'll see exactly what I'm referring to, but it's an awe-inspiring video to watch because it starts to talk about the possibility of what can be done, right? When you're applying pre-manufactured components, really effective planning, you put up an 18-story student residence in 9 weeks.
Dave, just one more quick follow-up from me, and then Joanna, just saw your hand there, and obviously we'll come to you next. Just in terms of that, panel-based systems and developing that infrastructure so that we can build these panels and designs of the future. Like, do you have any comments? Obviously, you've gone and seen some examples of where it's being produced elsewhere. How can we get involved in that? How can we grow Northern Ontario's economy?
So the good news is here in Ontario, I think we all are familiar with a gentleman by the name of Frank Dettori, and Frank and a group of his partners have opened up a new factory in St. Thomas, and they moved it to Southern Ontario because it's closer to the end use of the finished product, right? So from a density perspective, they moved it to a location where not only can they ship in Southern Ontario, they can ship into the Midwestern United States with very short distances. But all of their wood is sustainably harvested here in the province of Ontario, primarily in Northern Ontario, obviously. And then it's shipped to St. Thomas, where it's manufactured into these finished elements, and then shipped to various job sites across sort of Eastern North America is certainly the market that they're targeting. So the wood in our project will come from Element 5 and their factory here in the province. Up until Element 5's factory, Nordique had a factory in Quebec, but there was still a lot of this type of product being brought in from Europe. If you believe this, right, you think about what Canada does in terms of wood production, and we're bringing in these finished products from Europe. That makes me shake my head. I don't understand. But thankfully, we now have more capacity for this here in the province, and it's growing quite quickly. There are other manufacturers coming online.
Please go ahead, Joanne.
I was just wondering, Dave, I know there's fundings and grants available for municipal buildings and projects. Are there any for the private sector too?
Well, some of the ones I think we've talked about, energy retrofit. Alex talked about a few programs that are available. I understand that CMHC is talking about interest-free loans of up to $40,000 for doing deep energy retrofits on homes. So really upping sort of the ante in terms of saying, hey, we want to see this happen. The interest-free, I think, will catch a lot of people's sort of attention and get them to be interested in doing those investments. So the programs that are out there, I understand there's more coming. We've actually working with a small group here in the city that is speaking to some folks that are quite well connected sort of to those programs. And we're trying actually actively, Joanne, to see how we can create some critical mass in terms of sort of a variety of projects in North Bay that might put North Bay or would put North Bay on the map in terms of sort of our forward thinking efforts around sort of sustainability and energy efficiency. So I hope over the next couple months, some of the work that group's doing will start to take more shape, and will actually be obviously wanting to engage the city in a number of those discussions, because we see it as significant benefit to the private sector, to the municipal sector, to the community as a whole.
Okay, thank you.
All right, well, I mean, we're coming up to 7:45, so unless anybody's got any last minute burning questions, like going once. Oh, there we go, Kylie Ann, go ahead.
Jump in. Yeah. Thanks so much for that, Dave. It was so interesting. And kind of as Alex had said, when I first found out about passive homes and, the retrofit stuff, I was so fascinated and actually started running around my parents' house like this, looking for like air leaks. It's so interesting. So my question is, you kind of talked about how to get to our, 1.5 degree target, we really have to accelerate this work. And I'm wondering if you have any comments on the workforce required to get there. Like, it's a very specialized skill set to do these retrofits. And are we prepared to, have the people that have this training and their skill to do this work? Are they going to be kind of ready to do it at the pace that we need to, in your opinion? And if not, what do you think the solution is to getting there?
I've seen examples, I guess, in other countries, again, through some of those links that I've shared in my presentation, Passive House Accelerator particularly. One of the groups that we've been listening to speak is out of Ireland. So they have actually now embedded that training into their basically community college programs. And they've started to make sure that all elements of construction related to passive house type buildings or to high performance buildings is being taught at the trade schools. And that's what's got to happen, right? We've got to be able to embed this in our vocational training right across the various trades so that they can learn what it takes to do this. And you've seen a number of private companies pop up that are providing this kind of training as well, and trying to promote sort of that development of what they call certified passive house tradespeople. So when you take the passive house training, I've taken the engineering and design course, and then I took the PHPP, which is the modeling course. They actually also have a certified passive house tradesperson course. And then they have a hands-on component in terms of teaching you how to truly hit those air tightness levels that you need to hit in terms of getting the performance level that you're going to get. So we need to, I guess in the province of Ontario, we don't yet have the focus on being able to build that workforce. And provinces like BC are, I think, setting a really good example for us to follow around how you help the industry make that transition.
Yeah, I just want to give a quick shout out to College Boreal and Cambrian College and Canada College. You were all kind of investing in that space and doing different areas around sustainable building designs. But I think we'd all acknowledge that if this is going to be the new norm, we've got a lot more to do and we need to build that capacity. Sorry, Dave, were you going to comment on that?
No, I agree with you completely. I think there's good work happening. We just, I think, all understand we've got to try to do more faster if we can. And I think the job opportunities that exist sort of in that industry are massive, right? I mean, we talked about them earlier, I think, in one of the presentations, so, 53,000 or something green jobs in terms of those opportunities. So the Build Back Better motto of our first presentation is absolutely correct, right? There is a real opportunity here to create, sort of economic sustainability while we create environmental sustainability. These things can go hand in hand, and it doesn't have to cost us dramatically more. I would argue if we apply good prefabrication, apply factory manufacturing techniques to as many of these components as we can actually flatten that cost curve, if not bring it down.
Awesome. Well, I think we're gonna put a pin in that for now. Again, reminder, everybody, we've got a hot date on Monday. We've got Brene Lloyd's transportation options roundtable. So if you attended last week's session, you should recall that they're wanting to get North Bay residents' input on that. Thank you so much again, Dave. That was again fascinating, really great, and thank you all for your questions. I look forward to seeing you all next week. I'll be sad that we'll be ending the 5-week series, but it'll be great to see you there as well.
Carry on. We can do some more, Alex. We'll see.
Oh, yeah, true.
Any ideas on speakers, let us know.
All right. Well, thanks so much and have a great night, everybody. Take care. Thanks, Dave.
Good night, everyone.